Thank you, Isu. Next is Michael Opperman, received his master's degree in computer science from the University of Vienna. In August, he will start as a PhD student within Tamar Musner InfoViz group at UBC in Vancouver. His research interests include information visualization, human-computer interaction, and data-driven journalism. Come on up.
Okay, hi everyone. Today I will talk about the Bike Sharing Atlas. It's an interactive visualization system for the exploration of hundreds of bike sharing networks worldwide. This project is a joint work between Michael Ziedelmeier, Thorsten Möller, and me at the University of Vienna. Being increasingly digitized, these data produced by bike sharing networks can reveal interesting insights, not only into patterns of bicycle usage, but also into the underlying spatio-temporal dynamics of a city. And if we can leverage this data, we can create a benefit for our various target groups. So bike sharing. In our project, we put the focus on the traditional station-based bike sharing systems. So a user can get a bike, rent a bike at a specific station, drive to another station, and drop it off there. So these bikes are non-digitized. They have no GPS sensor, and they are not electronically connected to a network. But each station has a certain number of docking spaces. So each station has a finite capacity. The number of available bikes at each station, we call this the fill level. So the fill level, how many bikes are available at the stations, is a crucial factor for the functioning of a system. If you rent a bike and you drive to a station and the station is full, you can't drop off your bike there. You have to drive to another station, and this can be very annoying. So a better understanding of the whole system helps the operator or the city planners, public authorities to improve this system. As one example, there are further challenges. So in our project, we recorded data from many different sources over a long period of time, about 1.5 years. We combined the data and we created multiple visualization prototypes. In an iterative design process, we have worked with various user groups and evaluated our system and further improved it. And the result is this web-based visualization system. Here you can see the homepage of the Bike Sharing Atlas. And here we get an overview, and we can zoom in. And here we can see all the networks, and we can click, for example, on one specific network, Paris. It's one of the largest. And yeah, we can click on a specific network, like for example Paris, or we can switch directly to another network, Mexico City, where we can see an overview of the whole network, where each station is a circle, and the color encoding helps us to quickly get an overview of the current fill levels. So how many bikes are available at the specific station at the moment. So the blue circles, for example, indicate that the stations are full, so I can't drop off my bike there. And this feature is very helpful for general public users, for example. And so they don't have to go directly to a specific bike sharing network. They get an overview of all the cities on one platform. We can switch here to another tab. We've implemented a route planner for more than 400 networks. It works like similar to Google Maps. I can zoom in, define a start position, and it automatically finds the nearest bike sharing station close to my start point. The same for the end point. And it automatically calculates the fastest route between these 2 points. Unfortunately, there are some problems with PowerPoint, I think. So there should be a line from here to here. But we have not only worked with live data and with the locations of the bike sharing stations, we've also recorded historical data, as I already mentioned, over more than 1 year. So we have included more than 460 networks from all over the world, and we recorded station timestamps, so the current fill level from each station. And we get every 15 minutes a timestamp with this information. So we get the station ID, the network ID, the number of empty slots, and the number of free bikes. and the time and date information, of course. So all these stations, more than 22,000 stations combined, and over 1.5 years, we got more than 1 billion of these timestamps. And on the basis of this data, we could integrate further statistics and features in the bike sharing atlas. So we can go back to the route planner. And if we click, for example, on this symbol, we can, it should open a small chart where you can see the average utilization. So how many bikes are available at a specific certain point in time. In addition to this small previews of the average utilization, we have also integrated another features. We have here the availability tab, which is also built on the basis of this historical data. And now we can see here this huge multi-series line graph. And here a multi-coordinated view with all the stations. And we can see already a pattern. So each line represents one station in this line graph. So the average fill level is the y-axis, and the x-axis is the average day. So some stations are empty here in the morning, get full during the day, and again empty in the afternoon and in the evening. And other stations show the inverse pattern. So now it would be very interesting, where are these stations, what's so special about it? So we have developed this interactive selection tool where I can draw on top of the chart to select a specific pattern. And the stations get highlighted in all other views. So this pop-out effect, it helps us to quickly identify the stations. And I can see all the stations in the city center are highlighted. So all the people are driving from the outskirts of London to the city center because most of the people have their workplace there. And as mentioned before, if I hover over a station, I get this small preview with the chart where I can also see the average utilization. And I have a slide at the end where I can change the selection size. I switch again to another network, Vienna. It's much smaller. It's just 100 stations around the city center. And again to the fill level analyzer here. And I can also draw on top of the map to select a specific geographical region if I'm interested, for example, in a specific district. But I can also draw again in this line chart and select here specific stations. But we can't see these commuting patterns like before in London. Most of the fill levels are balanced. So we have a lot of stations that are very full on average or very empty. So we talked to city planners and public authorities, and this is the mixed-use development in urban planning is one reason for this in Vienna. So the people live very close to the workplace, or most of the people, instead of London, where a lot of people have to commute for more than 1 hour. But we can see another interesting effect. So I select here stations that are empty. And we have here in the left sidebar the elevation profile integrated. And we can see an interesting effect. The people in Vienna are usually very lazy, so they like to drive. They like to drive down, and the stations get empty. So they take the bus or the subway to go up the mountain. Or it's not really a mountain; it's 100 meters. And the operator of the bike sharing network has to move the bikes manually, and this is very expensive. So yeah, I will go one level up to an overview of the networks. Here we have included a small multiverse visualization, which helps us to get it's a good indicator for the size, structure, and density of these networks. So we can see here Mexico City again, for example. It has a very dense network with more than 400 stations, but only in a very small part of the city center. And at the same scale, with the very similar number of stations, Chicago can cover a much larger region of the city because the distance between the stations is much larger compared to Mexico City, for example, or to New York City and Manhattan. And this is a very interesting aspect for city planners and public authorities when they try to extend a network or when they try to build a new one. Yeah, we can also filter this view based on different characteristics, and we can switch to another view where we get high-level metrics for these networks, and we can create a ranking. But yeah, unfortunately, I don't have enough time to show you all the features of this bike sharing atlas, and I will go back here to the slides. So yeah, we started our project in Vienna with a collaboration with the local bike sharing operator, where we visualized only data from Vienna from the past 4 years, and we also looked at other solutions. So there are many other visualization and research projects. There are many other bike sharing networks, as you can see on this map. That's just the available ones in our project. And many of them share their data in open data libraries, but most of them have a very narrow and local view. So research projects primarily focus on one specific network or just compare up to 4 networks. So we thought it is a worldwide trend with shared opportunities and challenges, and it would help some network cities to look also at other solutions. And with this knowledge in mind, we started to develop this idea of a global perspective on understanding bike sharing networks. Our methodological approach is not really a sequential workflow. We continually record the data from these more than 400 networks. We still record it every 15 minutes. And yeah, we designed and implemented multiple visualization prototypes and evaluated it with multiple user groups. As you can see here, we have worked together with bike sharing operator. We have talked to public authorities on a city and on a district level. We had interesting conversations with city planners about the mixed use development, about the structure of these bike sharing networks, and about the usage scenarios of the bike sharing atlas. Urban sociology researchers also work together with us. They are very interested in these multi-city comparisons and the integration of demographic statistics, of course. This is part of the future work. And we conduct multiple think aloud studies to further improve and to evaluate our usability. The pre-processing workflow is built on Python. The data is stored in a MySQL database and in small CSV files. The backend of the web application is built on PHP and the frontend on HTML, CSS, and JavaScript. And the visualizations and the interaction techniques are built with D3.js, and the map is based on the open source software Leaflet. So yeah, our approach is beyond the classical user-centered design methods. It was highly curiosity and data-driven at the beginning, but we have worked with many domain experts, and we think they are still invaluable. They significantly shape the final product and the prototypes that we have built. In the future, we want to further leverage the global scale of the data. So we want to further integrate multi-city comparisons and high-level comparisons, and of course other in-depth analysis. So the recorded data provides just a basis for future work. And we also started with a car sharing project, and we think that our approach could also work for many other applications in the smart city world and also for other domains. Thank you, and I'm happy to take questions.
You're fine. Thank you, Michael. Are there any questions for our panelists? Please use the microphone in the center of the room. I believe they're trying to record the session, so that way your question gets recorded as well, and not just the answer. Mm-hmm. Any takers? Sir.
Hi, Michael. Great presentation. Thanks. Having used a bike share to get here today and having gotten to a station that was full when I got there, one thing I would suggest is maybe some predictive capabilities based on all the data you've got. And maybe maybe this exists, but an app for your iPhone rather than a website interface. But great presentation. Thank you.
So
I think you might push the button.
thanks. Today I couldn't use the bike, unfortunately, but I will try it in Washington too. I also checked it in our system. In Washington, it works really good, I guess, kind of, on average. But yeah, and it's also planned to make a responsive website. But it was also our plan to make this website responsive and working on mobile smartphones. But because of the statistics and expert features in this tool, we decided to just make a website. But it would make sense to just use the live fill levels and the route planner and put it in a separate app for Android and iOS users, for example.
So this will be an open question for all of you. Any decisions that are made after using your tools? How are decision makers using whatever it is that you've produced?
Me. So for the county profile, for example, we have pass-through grants. So if you're looking in a certain area where you have to know the percentage of the open space or you have to have a certain population threshold, that's how they're using it to use the demographic information. For the freight activity locator, we have certain fast lane grants that are coming up for that. So looking at, for example, a corridor that may have a particular industry of activity and identifying that's the freight corridor where you want to investigate for investment.
So the tools that we're building are part of a larger suite of software. So the California has been running PEMS for 15 to plus years. So there are many analysis tools that are available to them. This is a component of their sort of process, and they want to use this to sort of help them set the targets and to manage up to the federal level, but then allow them to then drill down into analyzing. So for a particular area, they're very accustomed to working in many urban settings. This is an expansion into some rural areas that they're also going to sort of analyze, and so that's kind of a new place for them. But I think they're going to use it for general macro decision processes, reporting mainly, but then drilling down into where they're unreliable and use it as a collaborative tool with their with the MPOs in the state.
Are most of your tools available just for the DOT employees, but not for the public?
So Caltrans PEMS itself is open to the public, and so about 2/3 of the users are non-Caltrans users, and so it's used by researchers and others to analyze data. We process different types of data sets, and this is a particular data set. For this component of it, because of the rules associated with the data sets themselves, it won't be public, but the general part of PEMS is open to everybody.
Most of our tools are available for the public. The only thing that we don't have public that we only use with our internal partners are asset management and our greenhouse gas.
In North Dakota, the system grid was requested by North Dakota legislative. So actually the system was developed for the public.
Our project was primarily driven because of the collaboration in Vienna, and this global approach was highly data-driven. So only after we got the first results, we had the chance to talk to specific user groups and further improve the project and go in a specific direction.
Thank you. Anna?
Sherry, I guess I may have a couple questions, especially if no one else has lined up. But Zenobia, I'm curious, did your team find that the story map tool from Esri was flexible enough to kind of work in everything that you wanted, or did you have to tailor your content to what they provided?
So full disclosure, we do have a developer on board. So it did start with story maps. Some of the things also had to use the JavaScript API as well. Other tools that we have developed, we moved away from the story map. So the engagement tool, that was just built on the JavaScript.
Okay, so you
Yeah.
increased the flexibility that
Yes.
way. Okay. And Michael, I'm curious, your platform, do you have a way built in for the different system users to share best practices or what is working to help stop full?
We started to develop an expert tool, so not for the general public, for city planners and bike sharing operators, but it's not available at the moment. But
It's not what?
not available at the moment. So it's just a prototype where we started, because it's very difficult so our goal was to make a tool for as many people as possible, and if we include expert features, then we can publish it on a web platform and make it as easy as possible to use for general public users. So
If there was a specific funding source for that, would that be like, would you pursue that route more?
yeah,
Or is
maybe
it mostly
that was
funding?
also one of the problems.
Okay.
Yeah.
Cool, thanks.
Hi, Michael, I have a question for you. I don't know how much time you spent analyzing the data that is coming in for bike share, but you mentioned that the bikes do get moved around by vans throughout the day, and that definitely happens in DC. I'm curious how that movement of, reallocating the bikes throughout the day shows up in some of your charts and how that might impact some of the analysis.
So in this charts I've shown to you today, it doesn't really show up because it's averaged over 1.5 years, and that was 10,000s of timestamps. But if we made some analysis, static visualizations, where we can see that bikes at a specific point were moved in a specific direction or from one station to another. But this is very difficult to make it on a global scale with hundreds of networks. So this only works, for example, we have studied New York City or Munich or Vienna more in detail, where we can see that this movement happens. And there are, for example, networks where they don't rebalance these spikes. They just let the network as it is. And this very often there are a lot of problems. And this is visible afterwards in also these charts, that we can see that many stations are every time full for weeks because no one is moving the bikes to another station.
I have a follow-up. Do you make the data available for all those systems through your website, or would people have to go directly to the system to get the data?
The raw data?
The raw data.
We plan to publish a repository with the raw data.
Great, thank you.
Yeah.
Any other questions? Sure. Okay.
Okay, and Sue, you said that you were having some lower response rates than perhaps you wanted from the locals, and you're trying to get more counties involved. Have you found any tactics that were most successful in getting better responses for your data collection?
That's a good question, actually. I was talking with one of the county engineers who was one of my students, and he says he's getting different systems. So they don't want to have 2 or 3 different systems to maintain their roads. So still we're doing some public outreach to encourage county engineers and tribal transportation planners to use. So we're going to go to some other conferences and provide more workshops and talking to leaders directly. So we're still working on it. Thank you.
Okay, if there are no other takers, could we give our presenters some applause? Thank you. So that concludes today's session 1A. Next is lunch. So if you'll have an opportunity to hopefully to interact with the speakers at lunchtime, and take that opportunity. And remember to go out and like our Wow Wednesdays out at Federal Highways Facebook. Thank you.